In this video, we're going to continue to deepen our understanding of exponents. In particular, we're going to look at zero exponents and negative exponents and what they mean for us and what we're going to do about them. So first, I like to start by just letting the cat out of the bag so you can see where we're going. So with x to the 0, that's going to equal 1. And with x to the negative 3, that'll equal 1 over x to the third. Now I'm going to go through a math pattern to convince you of how this can be. We're going to use powers of 2 to see how exponents work. But first, recall that exponents tell us how many times we are multiplying by the base. We're going to use this fundamental property of exponents to establish the pattern that we're going to be looking at. So let's say we have 2 to the 4th, and then 2 to the 3rd, and then 2 squared, and 2 to the 1st. And we already know how to deal with these. 2 to the 4th means we're taking 2 times itself 4 times, and that gives us 16. Similarly, 2 to the 3rd gives us 8, 2 squared gives us 4, and 2 to the 1st just means we have 1 2 being multiplied, so that's just a 2. So those things we pretty much already have, but what I want to do is just look at what's going on here on the right hand side. So if we ignore the fact that these are powers of 2, and we ask ourselves, how am I getting from 16 to 8? How am I getting from 8 to 4? How am I getting from 4 to 2? Is there one way I can describe that movement? And there is. One consistent way to describe that movement is each time we are dividing by 2. And that shouldn't be too surprising because over here we're going down in powers of 2. Powers of 2, the more we have, the more times we're multiplying by 2. So it shouldn't be too surprising that as we go down in incremental steps, it creates this division by 2 behavior, because that's the opposite of increasing multiples of 2. Well, continuing this pattern on, it allows us to see what 2 to the 0 would look like. If I just continue the pattern and I divide by 2 another step, well, 2 divided by 2 is 1. So we're able to see that 2 to the 0 actually equals 1. And that's going to apply regardless of what the base is, right? Because when we get to this point, we're going to divide by that same number, and any number divided by itself will yield a 1. So 3 to the 0, 1. 5 to the 0 is 1. Really, it works for any number except for 0, because then we would be dividing by 0. Alright, let's continue on. Why stop at 0? So let's dive down into negatives for our exponents. So 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, 2 to the negative 4, and so on. So to continue the pattern, we're kind of jumping to a new column here, but basically we're going to take this 1 and we're going to divide it by 2. Well, that's going to give us 1/2. Well, you could write it as a decimal, 0.5, but we want to keep them in fractions so we can see what's going on a little bit better. So 1 divided by 2 is 1/2. And it's helpful to remember here yet again that a fraction bar means division. So 1/2 is 1 divided by 2. Alright, let's just continue on. So let's say we take 1/2, we have half of a pizza, and we divide that in half, then how much pizza would we have? We would have 1/4 of a pizza. Now we're going to take that 1/4 of a pizza and cut it in half, and that would give us 1/8 of a pizza. And we'll take our 1/8 of a pizza. This is getting to be far too small of slices of pizza, by the way. It's just not enough pizza. But anyways, we're going to take our 1/8 of a slice of pizza and cut it in half again. and then that'll give us 1/16. So each time we break those down, it gives us these smaller and smaller pieces of pizza. Alright, but let's look what's happening compared to what we already have. If you look here, we divide by 2, so you could think of that as we're dividing by 2 to the first. And then, the next step up, we have a 4 in the denominator, or you could think of that as us having a 2 squared in the denominator. The next step up, we have an 8 in the denominator, or you can think of that as having 8 to the third in the denominator. And then our last fraction down here has a 16 in the denominator, but we could think of that as having 2 to the fourth in the denominator. So if I write all those in that way, that would give me 1 over 2 to the first, 1 over 2 squared, 1 over 2 to the third, and 1 over 2 to the fourth. And so, looking back to where we started, if we look at our denominators in these fractions, they're basically where we started, but now it has a positive exponent. So basically, what's happening here is it's almost like we're taking what we have, moving it to the denominator, and making the exponent positive. And that's actually how it's said a lot of times. But I want to be a little bit more precise than that. And actually, what I want to do is go back to this original statement we had and talk about that and what's going on with exponents in general. First of all, this statement that exponents tell us how many times we are multiplying by the base, we can now see that this isn't completely accurate. We've been slightly lied to, because the truth is that positive exponents tell us how many times we're multiplying by the base. Negative exponents actually tell us how many times we're dividing by that number. Negative exponents tell us how many times we're dividing by the base. For example, 3 to the negative 2 is actually 1 divided by 3 squared, or 1 over 3 squared. And then for zero exponents tell us we're not multiplying by that base at all. For example, if we have 3 to the 0, that equals 1. Now I do want to talk about this whole equals 1 along the sides of saying we're not multiplying by it at all, because that can feel a little confusing. Usually when we say none or nothing, we mean 0. But with multiplication, the thing that does nothing is 1. 1 times 2 gives us 2, 1 times 500 gives us 500, 1 times x gives us an x. So 1 means that there's nothing really there. That would mean that if we add 2 to the 0 times x, we're not really multiplying by the 2, so we just have an x. But that's the same thing as this guy. So anything to the 0 power is going to be that 1, except for the 0 to the 0 power, but we're not really going to be tackling that. Okay, so that's the idea. Now we're going to dive into a couple of examples to see how it'll play out. So our first example, our directions are to simplify, and with these directions to simplify, there's an important thing to understand with exponents. Negative exponents and zero exponents are not considered simplified. So we need to keep that in mind as we're working. If we have a negative exponent, we've got to do something about it. If we have a zero exponent, we have to do something about it. And now we know what we can do about it. So, for example, if we have x to the negative 3, well, we know that's really saying we're dividing by x 3 times. So that becomes 1 over x to the third. So for part B, let's say we have 2x to the negative 5. Here it's important to remember that only the x is the base. If the 2 were a part of the base, we would have parentheses around 2 and x. If the parentheses were there, that would say we are dividing by 2x 5 times. But in our original problem, since the parentheses weren't there, it's only saying we're dividing by x 5 times. The 2 we are multiplying by. What that ends up looking like is 2 divided by x to the 5th, or 2 over x to the 5th. The things we're multiplying by are in the numerator. The things we're dividing by are in the denominator. Alright, now let's say we have 3 over x to the negative 2. So this one's a little trickier because it's already in the denominator and it's a negative. So I'm going to kind of break this down a little bit for you so you can see what's happening. But in the end, you'll get to where you can easily move past showing all these steps. So first of all, to see what's happening, I want you to think of just working x to the negative 2 in the denominator as if it's its own problem. So we're just going to carry the 3 over in the numerator and do something about this negative in the denominator. Well, if the denominator is its own world, what I would do is take that x to the negative 2 and make it 1 over x squared. It's a little disconcerting that it's in the denominator, but just inside of that yellow universe, we've done what we did up here in A. Okay, so now I'm going to ask you to recall from your lost memory banks what it is that we do when we're dividing by a fraction, because this fraction bar here means we're dividing. So this is 3 divided by 1/2. So at some point, that may be lost in your past, you might have heard before that when you divide by a fraction, you multiply by the reciprocal. In other words, this becomes 3 times x squared over 1. So we multiply by the reciprocal. The reciprocal just means we take the denominator and we flip it, and we changed it from the division that we had, because the fraction bar means division, so now we have multiplication. So we take the numerator times the flip of the denominator. And that's just how you deal with dividing by fractions. That has nothing to do with the fact that we're working with exponents. Alright, so now I want to simplify this by doing the actual multiplication. 1 over x squared, x squared divided by 1 is just, it's just an x squared, because dividing by 1 doesn't change anything. So this is just going to simplify to 3x squared. Now, I kind of walked you through this incrementally so you could see what was happening, but you'll get to a point where you get comfortable with, if you look at what we had in the beginning and what we have here at the end, basically we took the negative exponent, that factor that was in the denominator, and we brought it up and multiplied it by what's in the numerator. Now, negative exponents still mean that this is what we're dividing by, but the interesting thing about opposites, and it works for opposite operations as well, is if you take the opposite of an opposite, you get back to where you started. So if you divide division, you get back to multiplication. And that's what's happening here. The opposite of an opposite is where you started. Alright, so that example helps us mess around with negative exponents. Now we're going to incorporate zero exponents in this as well in a second example. Alright, so we worked stuff with multiple variables and stuff when we had just regular old positive exponents. We're going to do a little bit of the same here. Now I'm going to first deal with my zero exponent. And as we've talked about, that equals a 1. So that would give us 2 times 1, y, over y to the negative 2. So all I did was turn my x to the 0 into a 1 there. Now what I'm going to do, you may be tempted to want to just deal with all of your y's in one fell swoop. And we are eventually going to get it together, so we only have one y base. But I like to take this in steps just so I don't get a little turned around on what I'm doing. Sometimes when you're flipping things around, you accidentally double flip. So first, I am just going to deal with the fact that I have this negative exponent in my denominator. And as we saw in part C of our last example, that means I can just change that to multiplication in the numerator. So that gives me 2 times 1 times y squared, and then there wasn't anything left in the denominator, so I'm allowed to just stop writing that I have a denominator of 1. So now I'm just going to multiply this up in order to simplify it, and that gives me 2y to the third. So that's fully simplified. We don't have any negative exponents left, and we don't have anything with a 0 exponent attached to it anymore. And so it's all done. Let's look at another one. Alright, negative 3 times y to the negative 2 times x to the negative 2 times y, all of that divided by y to the fourth. So a few different components going on here. I'm just going to deal with my x to the negative 2 first. So that x to the negative 2 is telling me I'm really dividing by x twice, so I'm going to put it in the denominator with a positive exponent. That gives me negative 3y divided by x squared y to the fourth. Now what I'm going to do next is deal with my y's. Now neither of the y's have a 0 exponent or a negative exponent, so this is just like what we were doing with exponents before. I have one y on top, I have 4 on bottom, so I'm going to start slashing them. The 1 on top is going to get canceled with 1 on bottom. I'll be left with 3 in the bottom. That gives me negative 3 divided by x squared y to the fourth. I want to contrast that with what I did up here. I did not do the cancellation technique up here, and the reason why is because I still had a negative exponent attached. As long as there's a negative exponent, you don't want to go into your cancellation mode first. You want to make those positive, and then they will work like we have seen in the past. But as long as they're negative, they don't quite work that way. I also want to emphasize that I did not really do anything with this negative 3. When we are talking about a negative exponent, means how many times we're dividing by the base, we're talking about exponents. Here negative 3 is a coefficient, and coefficients do not get to participate in the exponent rules, so nothing can really happen with that negative 3. The only way something could happen with a coefficient is if there is another coefficient for it to interact with, and then it would interact with it the same way that numbers have always interacted with each other before you learned about exponents. So we have here our final result. We're all done. And that's what I have for you guys. Go ahead and try some of this out with a few problems and see where you end up.